Hello, welcome to the video lecture on arrays. In the present video, we learn what is a two-dimensional array, declaration of two-dimensional array, accessing the elements of two-dimensional array, initialization of two-dimensional array, and input-output operations on two-dimensional array. Now, types of arrays. The arrays are classified as mainly two types, one-dimensional array and multi-dimensional array. If an array consists of only one subscript or one index, it is known as one-dimensional array. And if the subscripts or indices are more than one, they are said to be multi-dimensional arrays. However, conveniently, we discuss in detail about the two-dimensional array, which is a special case of multi-dimensional arrays. Now, let us know about what are the two-dimensional arrays. If an array consists of two subscripts, then it is known as two-dimensional array. Basically, two-dimensional array consists of a finite number of rows and a finite number of columns. Each row consists of a finite number of columns as shown in the table. See, the rows are indicated from the index I is equal to 0, 1, 2, etc. Similarly, for each row, each column is represented with an index 0, 1, 2, 3, etc. For example, if you take row index as I is equal to 0, 1, 2 represent the rows. And if you take the j as the index for the column, j is equal to 0, j is equal to 1, j is equal to 2, j is equal to 3, and so on, represent the column elements. So over a pair of row and column index represent an element of a two-dimensional array as shown in the table. Now, how to write a two-dimensional array and how to declare it? For that, we have a syntax, and the syntax is data type, array name, and row size in square bracket and column size in square bracket and semicolon, where type can be any valid C data type and array name will be a valid C identifier. A two-dimensional array can be considered as a table which will have X number of rows and Y number of columns. A two-dimensional array A, which contains 3 rows and 4 columns, can be shown as below. Now, how to initialize the two-dimensional arrays? Initialization means storing the data for the elements in the memory. Generally, it is of two types: compile time initialization and runtime initialization. In the compile time initialization, directly the values of the elements are given in the program itself, and in the runtime, the values are inputted with the help of input statement like scanf during the runtime through the standard input device. So here in the present slide, we have shown the initialization of the two-dimensional arrays using compile time environment. So for that, what we do is that we declare a two-dimensional array of data type int, and array name is simply A itself, and row size is 3 and column size is 4, so that 3 into 4, 12 elements exist in this two-dimensional array. Now, for giving the values of all these 12 elements, then what we do is that we put an assignment operator and we put a curly brace, and then again each row elements 0, 1, 2, 3 column wise have been depicted in one curly brace, and similarly the column elements of the second row are shown here, the column elements of the third row are shown here. Like this, all these elements are assigned to the two-dimensional array A 3 by 4. Here the row index is I is 0 here, I is equal to 1, I is equal to 2. The column indices are 0, 1, 2, 3, etc. The nested braces which indicate the intended row are optional. The following initialization is equivalent to the previous example. Here what we are doing, int a34, simply one simple set of single set of curly braces. We are arranging all the elements as per the sequential order. So this is also another way of initializing the two-dimensional array. Now, accessing the two-dimensional arrays. With the help of the row index and column index, we can access the element. Here, in this program, we are showing how an element is obtained or how the elements are accessed. Here int a52, that means 5 rows and 2 columns. So accordingly 1, 2, 3, 4, 5 sets of elements are kept here. And now by using a for loop, we are outputting the elements as element wise. For that we take for I is equal to 0, I is less than 5, I plus plus. And again we are taking an inner for loop for j is equal to 0, j is less than 2, j plus plus. And over the iterations on I and j for the given sizes, each time during each iteration, we can print the value of aij. So for all the iterations of the nested for loops, every time the value of aij will be printed like this. Because these values are already inputted here in the same order, row and column wise, the elements are printed. So thus we can access the elements of the two-dimensional arrays. Now storage elements in a matrix and printing it. That means it is the procedure how we can access the elements or store the elements in runtime environment. In the runtime environment, what we do, we use the scanf and printf statements. So here we are declaring an array of integer data type, array name ARR, and sizes are 3 by 3, and indices are I and j. In the first part, we input the values by using the standard input function scanf. And later, after storing the values, we want to print them, and that is why here we wrote a part for printing the elements on the screen. So here, when the for loop is executed for I is equal to 0, I is less than 3, I plus plus, first value of I is equal to 0, we are entering into the inner for loop. In the inner for loop, j is equal to 0. That means the first set of I and j is 0, 0. So here I and 0, 0, we are entering the value. So by executing the scanf statement on the through the keyboard, we give the first value of a00. Then the a00 value will be taken and stored at the place of a00. Now what happens? J will be incremented and I will be same. So I is equal to 0 and j becomes now 1. So next a01 element will be inputted, and so on continuously. A02 also stored. Now when all the elements are stored, this part of the program will be over. Now in the computer memory, for the array of size 3 by 3, all the 9 elements have been stored. Now in this part, by executing this nested for loop, every time we are printing the values as ARR 00, 01, 02, 10, 11, 12, and so on. All the 9 elements are outputted on the screen. Thus, in a runtime environment, by using the printf and scanf functions, we can store the data of the array elements of the array. Thus, in the present video, we learn what is a two-dimensional array, declaration of two-dimensional arrays, accessing the elements of two-dimensional array, initialization of two-dimensional array, input-output operations on two-dimensional array. Thank you all.